In this video, we will be assessing a GLDC nonsense variant for eligibility towards ASOs. As always, we must first check if this variant is correct. Greater detail on how this can be done can be seen in the ABC-A4 video example. This variant description is correct. We next check the inheritance pattern. We can do this using OMIM. If we look up the gene, we see here that this is associated with glycine encephalopathy and follows an autosomal recessive inheritance pattern. We next want to check the pathomechanism. For this, I looked up the variant on ClinVar. We can see here that this is an assumed loss-of-function variant, as it is a nonsense variant, and loss-of-function variants in this gene are known to be a cause of disease. We now know our inheritance pattern and pathomechanism. For step 3, there is no evidence of this variant's effect on splicing, and this step indicates that we can consider exon skipping, since we have a nonsense variant. So we can now move on to step 4, as suggested by our guidelines. Since our variant is loss of function and autosomal recessive, we can assess the variant for eligibility towards canonical exon skipping ASOs. To keep it simple, we assess for factors that call for quick exclusion when evaluating for eligibility towards canonical exon skipping ASOs, including checking whether the variant is in the first or last coding exon, whether it is in frame or out of frame, and whether a stop codon is formed. Using the UCSC genome browser, we can visualize the location of the variant. We see our transcript of interest here. Our variant is located on this exon here, boxed in red, as indicated by the yellow highlight. If we mouse over that exon, we can see that this variant is in exon 4. This exon is in frame and it is not the first or last coding exon. We also see that the exon phase does not start with 0 or end with 0. So that means the codons at each end of the exon are partially coded by the neighboring exons, and there is a possibility of forming a new codon if the two neighboring exons are joined, including a stop codon. This means we have to check what happens if exon 3 and 5 join together in the case of exon 4 skipping. Keep in mind that the transcript is read from right to left on the screen, so 5' to 3'. Therefore, exon 3 is on the right and exon 5 is on the left side of the screen. If we look at the 3' end of exon 3, we see this tryptophan codon, which is partially coded for in exon 3 and continued on into exon 4. This is the codon that will join with exon 5 to form a new codon if exon 4 is skipped. Since this is read on the reverse strand, our specific transcript will have nucleotides T and G. If we look at the 5' end of exon 5, we see this codon which is partially coded by exon 4. This is what will join with the codon on the 3' end of exon 3 if exon 4 is skipped. We see here that the nucleotide on the forward strand is a T. Since our transcript is read on the reverse, it is an A nucleotide in our transcript. This means exons 3's T and G will join exon 5's A. This forms TGA, a stop codon. We can now go to our eligibility table. We see here that a formation of a stop codon is not eligible for exon skipping ASOs.